Everyone, today we'll be doing a lexicologically smallest string problem. It's basically a string and an integer value will be given as a problem statement. Here you can see with an example given, like a string will be given and an integer will be given. Now what we have to do is, like whatever the integer has been given, first we have to check with the length, if the length of the string is like a power of 2. So if the length of the string is a power of 2, then we have to like reduce k by half. But if the length of the string is not a power of 2, then we have to multiply the k by 2 value. Okay, so that's how the k value will change according to the string length. Okay, now coming to what changes will be adding to the string, and since the we have to return a string as an output, so whatever the value will of k will be there. Like first we should see, here 1 2 3 4 5 6 7. So here the string length will be 7. Okay, so 7 is not a power of 2. So what we will be doing over here with the k value is, like we'll be multiplying it by 2. So 2 into 2, that will be 4. So there will be k value 4. It will, from 2 it will be changed to 4. And from this taking this k value as 4 and this whole string, now what we have to do, the operation in the string is like any from any position of the character. Okay, in this given string we have to delete 4 character with the highest ASCII value. Okay, or we can say like a largest character from the string will be removing, for k is equal to 4. Okay, so we have to remove k largest characters. So here we'll be, in this whole string we'll be seeing like the largest will be of FOOL. Okay, and the remaining will be A and D. So we'll be returning A and D as my string. Okay, coming to the example 2, here the length of the string is 4. That is a multiple, that is a multiple of 2, or not a multiple, that's a power of 2. So it will be reduced by half. Okay, so k is given as a 4, it will be reduced by half, so k will now become 2. Okay, so here k will become, from k is equal to 4, it will become 2, and my string length is CODE code. Okay, so here also we'll be doing the same thing what we did above, is like we'll be just deleting the two character that has the highest ASCII value. Okay, so if we will be deleting like a O and E. Okay, because A B C D D E comes after D, so O and E will be removing, so remaining the CD will be returning as an output string. Okay, now how we'll be doing is, this string is like, first we have to do some operation with the respect to k value. Okay, for that we'll be requiring length of the string. Okay, s dot length, we'll be taking out the length of the string. Then we'll be checking like if it's a power of 2. Okay, so we should just copy it in a new string, new number. Okay, because that will be modified again. So here we'll be copying it in another variable, and we'll be checking, like taking the num, and if it's a multiple, if it's divisible by 2. Okay, if it's completely divisible by 2, not bracket, this is not required over here. Num is equal to num divided by 2, if it will be divisible and it will be divided. Now if this operation is done, and if my final output becomes 1, that means it will be a multiple of 2. Okay, so here we'll be checking if my num is equal to 1. Okay, that means it's a power of 2, that num is a power of that num variable, whatever the value we had stored, that's a power of 2. So at that time we'll be doing like k is equal to k divided by 2. Okay, else what we'll be doing is like k is equal to k multiplied by 2. Okay, Now after doing this is like we have to perform some operation. Okay, now first we will be taking some variable. Now we will be taking it last. Okay, now we will be using a stack variable to store the values. Okay, each character will be storing, and we'll be checking for the next element which is present in the stack is largest. If it will be largest, then we'll be removing it. Like if it is a largest element, we'll be removing it from the stack. Okay, so for that we'll be using a stack of character, and we'll be naming as st new stack. Okay, new stack. And uh, for and we'll be also keeping a counter like remove. Okay, uh, remove that will be initially 0, because initially we have not removed any character. So for the string I'll be moving from 0 till my length n, and whole the string I'll be checking. Now in this, if my while is not empty. Okay, st dot is not empty, and my uh, remove is less than k. Like whatever the character we have to remove should be less than k. Less than means it should be less than or equal to k, then only we'll be proceeding with the remove operation. Removed is less than k, and mm, and my st dot peak value should be greater than s dot caret s dot caret I. Okay, now whatever the value will be lower. Okay, if it is greater than whatever the value we are pushing, so that time will be popping out the values. Okay, that means like if it's greater, then we'll remove from the string, and finally we'll be like concatenating all the values that is present in the stack. So will be if it's st.pk will be greater than the element that we are pushing, then we will be popping out the value from the stack, st.pop, and we removed plus plus. Since we are removing, so we'll be incrementing that, and this is under a while. So till my lower character is greater than the value that we are pushing, it will pop out the elements. Okay, and if this condition is not satisfied, like the element that we are having is greater than the element already present, so that time we will be just inserting the value into the stack. So it will be a push operation of s dot caret I. Okay, it will be a push operation of s dot caret I. Now if a whole of the array has already been checked, now even then my remove is less than k, so I'll be checking like while, like now this I am doing with a condition. Like you can see, like all the elements are in ascending order, like a b c d e f g is there. So at the time, like all the elements will be, like whatever the elements will be pushing, it will be always be greater than the element in the top of the stack. So all the elements will be pushed, none of the element will be popped out. So at that time we have to pop element from the top of top 3 or top 4 element we need to pop out. Okay, so for that we are doing this operation, like remove, like if my removed is less than k. Okay, that means whatever the element that is the largest, like foo, if it will be in a reverse order, like a and d fool, so it will be like pushed in the order in the stack, like a and d, and at the top fool would be there. Okay, so at that point we have to, the elements will not be removed from here, it need to be removed from the top of the stack just. So for this we are doing this operation, like for popping out the element from the top of the stack, and we'll be remove element, we'll be just incrementing this, so that it goes till my removed is incremented, and it goes to the operation that we have to perform, like in Okay, now after this operation while loop, okay, after this while loop, from my string, like all the largest characters that need to be removed is already removed. Okay, so now A and D is only kept in the stack but in a reverse order. Okay, since we are putting it in the stack, so it will be like A is the downward, N and D, and when we'll be popping out, like it will be DNA. It will be like a DNA. And what we'll be doing, we'll be using like a string builder to just uh, append all the character from the stack and just reverse it. So again it will be made like a and D. And since it will be using like a string builder, so we will also be using like a two string conversion of the class. Okay, now we'll be using like a string builder. Okay, area builder. Okay, SB, and new string builder, new string builder. And yes, we are using string builder, like can't like every time we have to append the elements, and then again we have to apply the reverse operation as well. So that's why we are using this string builder. And we'll be using like a while my st, that is the stack, it's not empty. Stack, it's not empty, that is empty. If my stack it's not empty, till then we will be just sp dot pop will just pop out the element, and to sb, that is the string builder, will append this. Okay, we'll append this st dot pop. Okay, now after this we'll be getting like dna, so we have to reverse the string as well. So sb dot reverse, sb dot reverse, and this will after reversing also it will be in a string builder, so we have to use to string. Okay, string function, and this whole thing we have to return. Okay, so we'll be using return over here itself, return over here itself. Okay, okay, we'll be checking with the test cases. Okay, but here we have not resolved uh, the base condition that will occur, like if my k is greater than the length of the string, then what it will be doing. So we have not resolved that. It got cleared up. Okay, can we have to wait like no, I'll not. My god, it got cleared up, submission. Just view from here itself, not going to write it again. Okay, now what I was talking about, the corner condition. Okay, so we have to resolve the corner condition as well, because here it's given like corner condition, like if my key value is like greater than the length of the string, so it then at the time it should return like a -1 in the string format. So this corner condition I'm talking about, if my k value after the calculation of k is greater than n value, so at that time we can't perform this operation. Like if will k value is greater than how than the length of the string, then how will be removing the elements. Okay, so that time we'll be returning -1 as a string format. Okay, so we'll just check out with the test cases. it's taking a lot of time. Oh, it had got as I just closed it, it got successfully compiled. Yes, and I'll submit. Now it's running for all of the test cases. Now you can try it out. Here we have used the string builder to append. Okay, and talking about the space and time complexity, it's like see, first here we are using like while loop. Okay, first we are using like while loop to check with the power, but it is just with the numbers. Okay, so here we are just moving from 0 to n and checking, and then in the interior we are moving to the, okay, it can even go to order of n square. It can even go to the order of n square as well. Order of n we are taking for the for loop, and for the while loop we are just moving to, okay, it can also go till order of n. It can see, while can also go to the order of n, like if we are just like we are putting elements, it will never go like, oh, elements is great. Oh, okay, if we are just pushing the elements like 5 5 5 5, okay, 5 times if we are pushing, okay, and the top element comes as 1, so at that time while we'll be running for whole of the stack elements and we'll be popping out element from the stack. So even for this while loop, the complexity can go as a n order of n, and at the top we have already like for with running for n times. So here I can tell like a space complexity is, time complexity is order of n square at a maximum, and space complexity is like we are using a string builder. Okay, but that too with the order of n, that will be object. Okay, and while order of 1, see, we are not using any extra space with the larger amount, so we can consider like a space complexity is a order of 1, but here the time complexity is order of n square. Yeah, in the worst case this while can go till n, but and at the top we have like a order of n, so n in the interior, it's like order of n square time complexity. Hope you are getting it. Meet you in my next video with another problem. Until then, do try out this lexicological smallest string. It's a medium level GFG problem. First you try it, you're doing yourself, and it's not just one method of doing it. There are many methods, like you can also use the priority queue, like for pushing all the characters into the priority queue, and then using the collection dot reverse order, you pop it the k out elements, and then the remaining you just again using the string builder you can do with this thing, and this will be just very easy, like whatever the stack operation we are doing over here, it's like popping and pushing, these all will not be required if we'll be using a priority queue. Okay, all the elements will be automatically arranged in that, so that we can use for making the things easy. Okay, so do try it out that way as well. If you're getting any problem, do put it in the comment section. I'll try to reply it, and thank you till then.